It's a catastrophic event we just observed. Two black holes, originally in a nice pair, like the Earth is going around the sun, but now because they're losing energy due to the emission of gravitational waves, they're coming closer and closer together until a catastrophic merger happens, destroys the binary, forms a new black hole. This in itself is the most powerful event we have ever detected as observers of the universe. The big discovery we're experiencing now has to do partly with this direct observation for the first time of gravitational waves, emitted directly from a black hole and being detected directly by instruments on the Earth.
The structure of the universe has a shape to it. And what you think of as a gravitational force pulling you towards a massive object in the universe is the shape of the universe being curved in such a way that you're falling towards whatever's at the bottom of that curved hole. So if you're a science fiction geek, right, you've probably heard the term gravitational well. And that comes from Einstein's description of gravity, that gravity is this shape of space and time together, that when things have a lot of gravitational strength to them, they create a deep gravitational hole, a well. And so you feel the force of gravity when you are falling down the well. So gravitational waves are a part of that story. Gravitational waves are the idea that that shape of space-time can move from one place in the universe to another.
Gravitational waves were predicted by Einstein just a year after he developed his amazing, counterintuitive, unexpected, innovative theory of general relativity about what gravity is. Even when he made that prediction, he actually wrote himself, yes, these waves must be produced, but there's no way we'll ever detect them.
So if you look at a picture of LIGO, it's this gigantic L shape. And that L shape is 4 kilometers from the corner building where it is, out to one end is 4 kilometers, and from this corner out to the other end is 4 kilometers. And we are constantly trying to measure the distance from that corner out to the ends of both of those arms. And the way we do that is we shine lasers back and forth, up and down the L. And we time how long does it take the laser to go one way and come back, and we compare it how long it takes the laser to go the other way and come back. And if we shine the laser out and they get back at the same time, we know the arms are exactly the same length. But if a gravitational wave comes by, it stretches one of the arms. It makes it longer. And so the laser that went down one of the arms takes a little bit longer to get back, and its buddy gets back first. And so we know that a gravitational wave went by.
The LIGO scientific collaboration is inherently an interdisciplinary collaboration. The center I direct here at Northwestern especially focuses on how astrophysics interacts with other disciplines. The same is true for our LIGO group here at Northwestern. So I work on astrophysics and data analysis. My colleague Shane works on astrophysics and data analysis across the gravitational wave spectrum. And another colleague of ours, who is not an astrophysicist, but is a physicist working in electrical engineering at Northwestern, is focusing on the laser physics aspects of this enterprise. It was a regular Monday at the office. I was at my Northwestern office going through my meetings all day long, but I always keep an eye on email, and I was receiving a few emails with little tidbits saying, there's something weird in the data. Has anybody seen this? Has anybody looked at that? I've ended my day, went back home, picked up my 3-year-old daughter first, went back home. I was ready to start preparing dinner and setting up the table when I get a text message. And I'm thinking, oh, it must be the weird emails. Oh my goodness. And then I drop everything, family and everything. Later at night, I realize, I have to tell Shane, who's my collaborator at Northwestern. So I emailed him late at night. It was almost midnight. I know Shane would be up because he's always up. And I said, Shane, have you seen these emails? And then I start forwarding emails to him and realizing, oh wow, there is a binary black hole gravitational wave signal in our LIGO data.
And we haven't slept since.
Yes. I find myself wanting to pinch me and say, is this really happening?
And now we're going to do all those things that only we've kind of imagined we could do, or that we want to do. And that's really what this is all about now, is that finally this thing we've been waiting around for 100 years to figure out if we can do, we know we can do. And so now it's all science all the time from here on out.